All right, let's begin. Welcome back, everybody, to another wonderful episode of Will It Explode? No, seriously. I think we're beyond the stage of explosions and breakage. I think we're in a really good spot. We're going to try to get some more of the coding done. So I welcome y'all back to our series of From Breadboard to Market, where we explore the crazy notion of taking an electronic project that we designed and running through the necessary steps to actually put the product on the market for sale. We're quite a few episodes in, quite a few. I know the recording and the uploading and the streaming schedule is all out of whack because of my real job, my full-time career has gotten busier, and I want to focus on that, and I don't want to burn myself out. So that's why I'm down to just streaming once a week and uploading once a week. Hopefully that'll change. Things will slow down. But in a way, I kind of hope they don't. Because it's nice being busy. I like being busy. So, where we left off last time, we pretty much got the temperature sensor working. Figured out our math and what we did wrong. Well, I didn't figure out the math. I had Copilot help me because figuring some of this stuff out is just too much of a headache. And math is not my forte. Which is weird, doing electronics and doing work like this and math not being my forte, not being my strong suit. But, you know, it is what it is. So before I get started, I come up with an idea to help me out. Let's see if we can get this going here. All right. So I want to show you something. So an idea I had to make life a little bit easier. So for the stencil printer, to make my life easier for stenciling PCBs, rather than monkeying around with those guys, you know, trying to get them in the proper position and worrying about them coming loose between stencil prints and stuff. It's just a pain in the rear. I designed a holder that I could just drop the PCB on, and it's mounted to the actual plate, and it's it's not going to budge. It's not going to budge. And it's reproducible. So it keeps everything square and in line along the X and the Y. So getting the stencil organized or lined up with this thing was a breeze because of this. Because you've got a lot of movement on the Y-axis. And left to right, or the X-axis, you really only have just limited bit to adjust your rotational angles, or to kind of, you know, nudge it left or right. So once you get the core stencil in the holder and lined up as best as possible, your fine adjustments are with the positional knobs. Fine tune those in, and it'll pretty much stay as locked as possible. And this will just help ensure from print to print, it's easy to repeat. And I think I'll do that for any project or anything I'm going to be building per se beyond the prototype stage, is just designing one of these holders for it. That way I could switch between products much more rapidly and just make my life a lot easier. Simple adjustments. Even if I have to figure out ways to hold larger panels, you know, given the build volume of my 3D printer, I'll do whatever I have to. We'll figure out solutions, even if it's just like, you know, hitting up individual like quad, you know, hitting up the four corners and just kind of figuring it out, making marks or whatever. We'll figure that problem out. But this will help in the long run. It'll speed up assembly in the long run, and we'll be fighting the stencil printer less and less between projects. So I'll grab my phone. Yeah. So let's get this guy wired back in, up here. Back to... And I accidentally hit something on the phone. Stop. Oh, gosh, this thing's so annoying. You accidentally hit one little thing on the screen. You just get a little too close. And it wants to bring up, oh, hey, would you like me to look for you for the internet on the internet for that? No. Leave me alone. So we're back to this guy. Chug, 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 get the motor speed really slow, the default speed. I might go ahead and let's go ahead and menu screen. Let's go ahead and go over here. You know what? No, let's not. Because the good thing about starting with a low value is you're less likely to have things just explode on you. So let's get this guy loaded up for the RS-485, COM24. All right, so here we go. Motor speed. There we go. Now we got a little bit of faster action here. There we go. And I think it's holding up pretty well. Everything's been working pretty good. So let's go back to here. Let's get count 254. I mean, so the NV, the non-volatile storage is working. It's storing the count cycles and everything. That's working. I think one of the last things we want to kind of touch up on is the status byte. I want to make sure that we're getting the information in properly. So let's go over to the main. So we have a first status byte. One of the things I can't remember if we established how we want the status byte organized. So we want so it's a full byte. So we've got 8 bits. And we're just toggling the bits as just kind of like generic fault source, things like that. So the two most apparent immediate faults I can think of that we're obviously kind of looking at is the limit status fault right here. So we have to kind of make sure we throw it here. So right here is the flag. Now, that's status. Now this works, but I see another way to set it, and all right. So let's just go ahead. So down here, this actually clears the status byte. And this sets it. So bit position 0 is going to be, so I'm going to use this other method. I said programming is not my forte, so I have to kind of look. All right, so that should set that. And this will clear it. Oh. So that should, so one will set the status byte at position 0. And this will set it to a 1, and this should clear it back to a 0. So hopefully that works, because then in the system status, it's monitoring it. It is. So if the status byte itself, if anything is in there set, so if it doesn't equal 0, it's going to automatically set the status pin LED. So we'll have to so let's get this new behavior. Let's see if we can build it. And then we will flash it. Yeah, it doesn't like the way I've got this written, but hey, that's fine. They work, and I don't care. I don't care. And there's one that's even unused. TX task. I might actually just go and pull that out. Clean up things a little bit. All right. So let us turn this guy off. Flash it. We are flashing. Super magical powers. All right. So, if I'm right. Okay. Let it go slow. It's fine. So if the limit switches pop off, status byte automatically goes red. Woohoo! That's working. So we have no real way of clearing. Well, it shouldn't just clear if the problem automatically gets resolved. Weird. So if I do a get status, it clears it. Maybe because something's not updating, I'll have to figure that out. But let's go ahead and fault it again. All right. All right. So somehow that forces it to clear. We'll have to figure that out here. Okay. We'll have to figure that out. Not 100% sure what's going on. But it does get cleared. It does force you to turn the enable off, though, before it'll restart. So I guess that's fine. So that's that. Why is it cleared? It shouldn't clear. Okay, that should not clear. Eh. Okay. Okay, so the limit. Okay. That can only fault if it's an enabled. Which makes sense. Because it only fault that out because in the main right here, only if we're running. So if right here, control status. I'm just trying to figure out why it's setting it to 0. I have to work through that. So here. So technically it should only do anything. So right now. Keep hitting the wrong thing. Okay, so it's still showing a fault, but if I turn off the enable, why is it still clearing the fault? Maybe we should do the okay, maybe the logic needs to move. Maybe we need to move this logic out. Okay. So maybe we should do a primary second. Primary safety check. So if we move this out of here. So what we need to do is we need to actually put that in the primary while loop. And that way it tells it to stop no matter what. So let's try that. Because I want it to completely fail and never clear that status byte. If those limit switches are disconnected. I want to try to mitigate any potential issues to where, especially with the limit switches. All right, so there we are. All right. All right, so I think that even without it running now, the minute we disconnect the, yeah, I probably should try to do something different here. So what I did was in the code, we pulled the checking for the limit switches outside of this loop, loop right here, put it in the primary while loop. That way it checks for that first. It makes sure the limit switches are actually reading properly. So will it run? Okay, so it runs. So we're okay with the limit switches. Will it? All right. So it runs. Okay, so we're running, we'll run. So obviously that's doing it. That's doing what it's supposed to do. So it's, mind you, it's not enabled because that's not engaged, that's not green. All right, good. So we've got the status LED. All right. Now, let's get status. Okay. Okay, so now if we plug these guys back in, does it clear the status? Yeah, so it clears it. Okay. And it clears it automatically. Why is it clearing the status automatically? So what's happening here? So in here, so this shouldn't clear the status. And it shouldn't clear. Well, this shouldn't clear the status either. That you shouldn't clear the status down here. Let's see if that'll fix it. I want to make sure that it can't just automatically be cleared. Gotta figure out why the status byte is getting. It should not clear. We'll figure that out. We will figure that out. Okay, so we're going to disconnect the limit switches. We have a red light. Gosh. Okay. Got a flag. So why is it clearing? Okay. So let's see. Get status. Okay, so we're in the monitoring. If status byte does not equal 0. So it shouldn't be setting that status byte in here. So is it the RS-45? Wait a minute. Set status. I think it's in here. Wait a minute. Is my logic screwed up? Ugh, wrong button. I need to compile first. You big dummy. Is that where the problem is? Is it just setting it? Maybe that's supposed to be a wound? Maybe all of these are broken? Okay, let's flash. Because I don't want it to clear it just by looking for the stat, like getting the status. All right. I want to be able to. Okay. Okay, we have a flag, so. Okay. Okay, because it's disconnected still. Now, will it clear it? Yes, it's clearing it. Why is it clearing it? So, all right. Let's take that out. Let's not let it clear the status valve. Because I don't want the RS-45, just because you communicate on it, that it'll do that. I want it first, and then I want to make sure that's where it's coming from. Okay. Flagged it. Okay. Now let's hook it back up and see if it clears it again. Clears? What the? Why are you clearing it? Okay, so this isn't doing it. So it's not coming through here. System status. Status byte. So when the system loads, this creates and then it initializes it. All right. So it initializes the byte at 0. It initializes the GPIO pin for the LED. And it initializes the task. So status byte does not equal 0. Nothing in here is setting the status byte. Hold on. All right. Status byte. That's right. So we have oh. All right. So the NVS system that uses this, that's using the status byte 2. So I wonder, let's clean up these status bytes. We'll come back and revisit these. I just wonder if they're causing a problem. Anything else? Is this guy using the status, touching the status byte? No. DRV. It does use a status byte. Let's. Okay, UART console. No. RS-45. Let's see if fan doesn't touch it. So now let's see with disabling anything else that could be touching it. Because that's weird. That's just weird. Unless my logic is completely way out there. Okay. I'm going to disconnect. Which all that's handled in the main loop right here. Right here. So in the main while loop, super loop. We're looking at limit 1 status and limit 2 status. If they're neither of them, if oh, okay. If either one of them just sets a status byte. That should set it. Nothing else is setting a status byte in here. All right. Okay, so okay, get status. Should be 1. Why is it kicking? How is it? Where in the world is it setting it to 0? That's what I need to figure out. Something is so messed up in my logic here. That yeah, the only thing that is it should be touching that. Mm. Hmm. Okay. Confuse ourselves even more. Is an error. All right. So that should be an error. All right. The status byte does not equal 0. Error. Or is an error does not equal false. So here is an error. Is an error true? Oh. Okay, so maybe I have to actually do just a 0 or 1. Where are you at? Oh. What? I thought I said 1. Stop punching me in the face. Come on, guy. The thing is I don't want to clear the error. If that doesn't work, I will punch myself in the face. Okay. Light comes on. We're in error. Okay. Okay. Perfect. Now, okay. Boom. Problem solved. Okay. So then we're going to click. Limit switches come out. We are in error. Jesus criminy. All right. Boom. Now, just by connecting the limit switches, shouldn't fix it. And it doesn't. All right. Yeah. Okay. Okay, that still forces us to disable and then re-enable for it to continue on, that's perfect behavior. I'm more than okay with that. Boom. All right, so that solved that problem. We just had to. Okay, so so you're forced to manually clear the error. I mean, resetting the system will clear the error too, but so no big deal there. So that does that. All right. So that cleans that loop up. Is an error. So we want to is an error equals 0. We will do that here when you set status. Okay. That way it oh, maybe this will screw me over. Let's find out. Because that's a spot where the status byte can be okay, let's test this out. We'll make sure it can't re-clear it. Okay, just by the fact that we type commands in. Oh. All right, boom. Okay. All right, good. So that should set that bool back to 0. And that way it becomes a secondary check. Sanity check. Perfect. So we have that cleaned up. All right, so here. So we know we want. Okay, so bit position 1. So that'll set an error. So, okay. Is this pulling the system status? Yes, system status. So we are, if we go here, so we want to set bit position 1. And default, okay. All right, so we have that. And then we come to the NVS system. This is where a bunch of other faults are. Okay, let's find where I commented task. No, it's right here. So we want bit position 2, which would be NVS error. Okay. So we want 2. Let's go with bit position 3, which would be NVS flagger. All right. Three. This will be, yeah, basically general. This will be bit position 2, general error on the NVS system. This will be the same thing. So those are going to be just general faults on the non-volatile storage system. They'll flag the status, and you can pull the byte. We might see about a way to decode that byte. I have to do it in the RS-45 in here. When you do get status, so we might have to. So in here, it's not like stuff we need. It could be a private. It'll be a private. So what we're going to do is we're going to void A5 all right, let's try that. Well, we're going to grab this. Get status. All right. We'll do that. But we're also going to run down to the status decode subfunction. You know what we could do? Buttons. Let's do an enum, a simple enum maybe, or we could even. Yeah, so let's go up here. Do it up here. Status codes. All right. Maybe we'll get this. Who knows? Status codes. Alt. Zero. Comma. Five. Equal 1. Two. Do I end that with a comma? No. And then this goes here. Boom. Maybe I'm doing it wrong. Maybe it needs to be backwards. 1 equal or 0. Maybe it's this. No, I don't know. I don't know. Figure it out. Because you know what? The worst that's going to happen is it's not going to work. It's going to puke its gut out and it's going to punch me in the face. Let's first see if it will compile. If it doesn't compile, I know I got something wrong here. Yeah, of course. So it's all broken in here now because of me. You know, how do I use chars in it? I think that's why it's broken. Okay. Why are you breaking? Oh, wait a minute here. I want to. Okay. And then down. Gaggle. Google. See, I got to be specific. I don't want it. Give me Python. I want it to give me C language. How do I accomplish this? Come on, Copilot. How do I accomplish this? All right. Oh. And so basically a lookup table. All right, well, let's try this here. Get rid of this garbage. Okay, let's use Copilot's help on this. It's got to do a better shot at it than what I tried. Key. All right. Okay. So we have a struct, okay. Okay. All right. I could make this smaller. Okay. One. All right. Okay. And then we can expand that as necessary. Let's make sure it compiles. It's mad because I'm not using it anywhere. Oh, all right. So if we go here, status to code. So it's going to need to do some things here. All right. All right. Let's go ahead. That as a function prototype. So what it should do is the decode. Let's first see if it compiles. Treat this as a non-void function. $3.15. There's that one. Did I translate something wrong? Why are you upset? Error control reaches a non-void function. So is it 313? Okay. Oh, maybe. Okay, maybe because I forgot to type that in there. Yeah, because I forgot to add that in there. Oh, my big dummy. Okay. So now the status to code, we need logic 2. All right, so let's go up one of these guys here. All right, let's kind of use that as an example. So we need a response. Error flags, errors given are. Error. Okay, so we need to. We'll worry about fixing that here in a minute. So if we go here, okay. Let's see. All right. So we know we want to do it in the status byte. I want a simple, easy way to pull that bit out of there. Carry bit. Okay. If bit. Oh, status byte does not equal 0. Think about how we're going to logically loop through the status byte. Because I want to be able just to quickly look through the byte, check to see if the bit, if the flag, if that particular flag, like at 0, bit position 0, is set high, and to go down and add the look down here for the key of basically 0 in that lookup table, and then add that to the response, and it could just keep adding that to so if the status byte does not equal 0, just think about this. Okay, if status byte 1 0 does not equal 0, Response. When we compile. Print F. Yeah, okay. Okay, so we'll see if we get see what we get. All right. Okay, so let's see here if we get a status now. Okay, so we get status. So it should go down here to the decode. Oh. Maybe it needs to be in here. So I just let the limit switches out to see if we get a fault. Okay, so there's still something wrong there. Something in the logic here. Let's see if there's like a different example. Maybe. Bit. All right, let's try something here. So let's try this little example here. All right, let's throw that up here on the functions of functions of functions. All right. All right. So that should check to see if that. The status byte does not equal 0, which is fine, because that's the same logic we're using to. I know we're going a little bit longer, but I want to try to get at least that working. So going to create a whole new. Okay. Oh, equals. Let's see here. No, I equals 0. Less than 8. The for loops, we're going to iterate through there. Iterate through. Now equals. Equals. Test. and mm-hmm. All right. Does this, or will it peek its guts up? All right. It's probably because it fell. No. Mm. Oh, geez. Okay. Oh. Yeah. It's as if I don't know how to write a for loop. Apparently, I don't. All right. I just want to see if it works. If it doesn't, it's fine. All right. So, why are you? Add us to code. Oh, Jesus criminy. Bet you that'll do it right there. At least we're getting the one, which is fine. All right, it did something there. Okay, so status decode. So put a status byte. Let's bring this guy back. Because I did do that. It did throw the new character, the new line in there. So still in the new line. It's not going through this. Well, it's like, oh, wait a minute. Look up response. Maybe. All right, so we have some failure going on here. That's fine. I wonder if I just take this. Yeah. Okay. All right, so it's not. We have the lookup table. So lookup response. Hmm. Lookup table. Lookup response. Lookup table. Hard to find that, maybe. If this doesn't work, we'll quit for the day and then get back to it next week. Because we are definitely seeing the status byte is and it's trying, so the logic is let me let's try one more thing here. Let's see if that confuses its guts out. Okay, so it is iterating. Okay. Okay. We got something different. So it does. Okay. Bit test I. Okay, so we're going to iterate. We have the bit value. Goes down here. It's going to be I and the status byte. Oh, wait a minute. Bit val. Is that where my dumb butt messed up? No, something. I'm still, my logic is somewhere screwed up. So, if we will figure it out. We will figure it out. You know what? We're already a little over. Let's see if we can figure this out here. So if position 1, let's say position 0, Okay, so if the bit value for that position so if the bit value of that position so lookup response, well, that's the key. So that if it's a okay, so if it's a 1, we need to then, if it's a 1, integer of I would be 0. So we'll look up the response table for at 0. All right, let's try this. Still. Okay. Bit times I. Wait a minute. Oh, wait a minute. What if I go? No. No. No, I don't have to do that. I'm doing something wrong here. So it's in print. Okay. All right, yeah, so no, I'm using it right. Am I doing a for loop wrong? What am I doing wrong? Because I could be. I could have my for wrong. All right, so it's like it. Let's get rid of that. Let's go to. Oh yeah, we'll try one more thing. This doesn't work. All right, it's not equals 0. All right, if this doesn't work, we'll call it quits here and get back to it next time. I really want this to work though. All right, we will figure out what's wrong. And we'll get back to this later. I could be wrong here in this logic. I wonder if I can just. Hold on. Let's see if it's even reading the bit data. Don't like doing this. It's sloppy, but it's fine. Okay. Is bit valve. Figure since we don't stream that often, a little longer of an episode won't be that bad of a deal. Come on. Okay, it's iterating. Bit value is 1. So it's going through 1 and they're all zeros. So, okay. Okay, so the bit value, it is coming back. It is getting the bit value. That's working like it's supposed to. Maybe we just need to... All right. All right. So it's the pipe's working. So if we go here, let's go and comment this out. So it looks like there's a break in the lookup response. Oh, you know what? I bet you we might well figure this little puppy out. Okay, so it's sending the pipe. It's not sending this. Char. Let's see. All right. Mad. I hate trying to figure out how to use chars and stuff. Probably won't work, but let's find out here. The air's never. Okay. Oh, you know what? Oh, maybe we're being too. You know what? We might be. You know what? Maybe I just made it too complicated. We're just looking up an index. Let's grab these guys, which is like an array of chars. That's basically what we're trying to do here. So let's get this cleaned up here. Okay, that's the lookup table. So what we're going to do is in here we're going to all right. All right. Oh, I probably forgot to do that. Yes. Mm. See what happens. Eh. Use Louise. Wow. Okay. Get status. It's still not working right. Oh. You know what? I wonder. If I'm just like shooting myself in the foot. I don't know. We'll see. Oh, okay. It worked. Oh, that was probably the whole problem. The problem the whole time was I was just overwriting my response. So maybe instead of adding that, so we need that, but we don't need this guy anymore. All right, let's get rid of that crap. Let's get rid of the lookup table up here. Good response. Is that still something that we're doing? No, that's fine. All right, so let's hit a new line, which is fine. We don't need to put a pipe after everything. Oh, okay. Let's just go and do another. We fuddled our way through it, and I think we got it. Limit fault. You know what? It's working. We have it working. All right. So then, all right. So if we, let's just go ahead and put the limit guys back in here. Oh no. Oh no. 0. All right. Zero. Oh, perfect. I'll take it. I'll take it. I'll take it. I'll take it. So let's just. You know, it's fine if we do this. Clean this code up a little bit. And we're going to compile it. We're going to shoot it over, test it out real quick. Getting there. We are getting there. Okay, and we're going to fold it out. Red light's on. Limit fault. Yes. All right. Set status. All right. Beautiful. I mean, the only way to really test any of the other faults is to purposely mangle the code. And we probably will on some of the stuff. We'll see what we can do. We'll have to kind of lie to it. But for now, it's working. We can rock on and maybe actually go into long-term testing. Maybe the next stream we will kind of clean up some things, organize some things, and get the unit ready to actually do the long-term testing while we switch our focus on finishing up the fan tester and getting documentation done. And in that process, I can start switching it over to get ready for actual production and to tidy things up. Because one of the things I want to do is go through, clean up all the code, get all the licenses cleaned up, you know, get all the readmes going, get all that nice and clean and organized. And then I'm going to take this code for the core example once it's all cleaned up and tidied, and basically clone it into its own separate Git repository, because it'll be shipped with the unit, and that way if anybody wants it, they can pull it down without pulling all the other stuff down that's associated with the project. But we'll take care of that later, because there's going to be plenty of stuff for us to do even while this is running its testing, because we're actually getting closer to the finish line. We're actually getting closer now that we've got the example code written. So what we'll do next week, like I said, we'll clean some things up. We'll get the enclosure wrapped up, get the fan installed, the cover on. That way we can start actual long-term testing. We'll reset the count, and we'll just go. That way we can test the belt. We'll get things kind of configured. That way I can monitor it from my office. Just let it run here in the workshop. And just check it every so often. You just see how long that TPU printed belt will run. So I thank you for hanging out with me. I really appreciate it. And you have a good rest of your afternoon, and we'll see you in the next stream. Take care. Hey, you too. You have a good day too. It was nice seeing you again.